Hi everyone, this video is about a derivative shortcut called the quotient rule. Tell you what the quotient rule is, I'll provide a proof of it, and then go through some examples. The proof is not in the video, it's something that you can look at on your own later. It's not tested, so it's also something you can skip. Product rule, or rather the quotient rule, says the following. If we're taking the derivative of f of x divided by g of x, the shortcut that gives us the correct instantaneous rate of change at any x coordinate is, it'll be g of x times f prime minus f times g prime, all divided by g squared. This is a difficult formula to memorize. There's other formulations of how you can write it. You could call the top function t and the bottom function b, and then hide the bracket x, make it look a little bit neater. Then with that alternative labeling, the top, instead of gf prime minus fg prime, would be bt prime minus tb prime, and the bottom would be b squared. I like this formulation because tb stands for something bad, tuberculosis, and we're subtracting it. We're subtracting bad things. So this has always been my way of memorizing it from the first time I ever learned it. I forget if it was the prof who said it or it was a classmate who said it, and I've remembered it since. Subtract tuberculosis. So if you want to, you can remember in this formulation, the derivative of t over b, derivative of top over bottom, is bt prime minus tuberculosis prime tb prime over b squared. A warning is that it's commonly mistaken that when you see a quotient or a fraction, the derivative of that is the derivative of the top divided by the derivative of the bottom. This is not the case. This will give you the wrong answer. We'll start with a very, very silly example where the quotient rule is completely unnecessary. X to the 4 over x to the power of 2. Why is it unnecessary? Because we can simplify first and then take the derivative. But this is a good test. This is a good verification process prior to looking at a proof. This gives us confidence that the formula is working. Okay, so I'm going to call this the top function over the bottom function. Then the quotient rule says, the hand goes up, do I need to write quotient rule if I use a quotient rule? No, please don't. It's okay if you do though. So quotient rule says that h prime of x is bt prime minus tb prime all over b squared. Okay. Now I'm going to plug in the ingredients. The b is the bottom function, so x squared. T prime, I'm going to put square brackets around it just to help me later on. Well, that tells me, okay, that's the piece that came from a derivative. It's just a bookkeeping device. So when I come back to look at this in 5 minutes, I'll be able to easily tell what came from where. Derivative of x to the 4 is 4x to the power of 3 minus t, x to the power of 4, multiplied by the derivative of x squared, which is 2x, or 2x to the power of 1 with a 1 hiding, and then all divided by the bottom squared. Be careful here, it's x squared squared. It's already squared, but we still have to square it. So whatever's down in the bottom, it's that thing all squared. All right, this is a horrible looking mess. And sometimes the answer will be left this way. It will not be simplified. It'll be, yep, just leave it alone. Don't do anything to it. And sometimes we will simplify it. So I'm going to continue simplifying. And I'll put a comment that sometimes the answer is left like this. Okay, so simplifying x squared times 4x cubed is 4x to the power of 5, x squared times x cubed, x2 plus 3, and then we have minus 2x to the power of 4 plus 1, so x power 5, divided by x to the power of 4. Upstairs we have 4 of something minus 2 of that thing, so it's 2x to the power of 5 left over x to the power of 4. We have 5 powers of x upstairs, 4 powers downstairs. When we cancel, we'll have 1 power of x left upstairs. That's our answer. Okay, let's check, because it's so easy to check this one. H of x is equal to x to the 4 over x squared, which is just equal to x squared. The powers cancel, the powers subtract. Now we'll take the derivative. H prime of x equals 2x. Hey, it matches. Not a proof. I could have just cooked up an example that this formula just happens to work for, but at least it's consistent. Okay, next question. We also have a shortcut for this. We could say that this is x to the power of -1, and then take the derivative with our power rule. I didn't use that name. It's for x raised to a power. When we take the derivative, the power comes down, the new power gets reduced by 1. So what would happen here is we'd get -1 times x to the power of -2, which is the same thing as -1 divided by x squared. So that's the answer. I'll put that down at the bottom as our goal. I'm kind of pre-checking. So this is what we know has to happen based on what we've already learned. H of x equals 1 over x, which is the same thing as x to the power of -1 using the laws of exponents. Now we'll take the derivative. We get negative x to the power of -2. Power gets reduced by 1, which is -1 divided by x squared. So that's our check. Okay, let's confirm that the quotient rule agrees with this derivative. So this is our top function, this is our bottom function. bt prime minus tb prime all over b squared. You know, I've marked a lot of tests, a lot of questions, a lot of functions that look like this, like 1 over x or 1 over x squared. I see so many people using the quotient rule, and I'll hand it back and I'll ask them, why are you using the quotient rule for like the derivative of 3 over x squared? And they'll say, because then I don't have to do exponent laws. Sad baby sounds. I'll have to investigate in a minute. Okay. So we gotta be careful. The bottom function is x. T prime, the derivative of 1 is 0 because 1 is a constant. Minus t, 1, times b prime, which is 1. So I'll label these. D by dx of 1 went there, and d by dx of x went there. All divided by the bottom squared, which is x all squared. Okay, we simplify. 0 minus 1 over x squared, which is minus 1 over x squared. It's the same. This could also be a dirty trick. I could have just made up a function that this rule worked for, and I'm tricking you all. I have not proven the quotient rule using 2 examples. Even if we did 1,000,000 examples, it wouldn't prove the quotient rule, just like 1,000,000 examples wouldn't prove the product rule. Okay, we have now come to a question that we need to rely entirely on the quotient rule, because we cannot split this one up. We can't use tricks to turn this into something that the power rule, that x to the n, and related rules like constant times a function, like we can't decompose this into a function that allows us to use only the simple rules. We need the quotient rule for it, and we'll have no way to check it. So the top function I'll call t, bottom function I'll call b, and now we put our trust entirely into this unproven formula. bt prime minus tuberculosis divided by bottom squared. So the bottom function is x squared plus 1. T prime, the derivative of the top, derivative of x squared is 2x. Derivative of 1 is 0 since 1 is a constant, minus t, so x squared minus 1, times b prime, derivative of x squared plus 1 is 2x plus 0, all divided by b squared. X squared plus 1 all squared. Okay, let's simplify. So we have x squared plus 1 times 2x. That's 2x cubed plus 2x. Expanding that. And now we have minus 2x cubed plus 2x. So why is it plus? Well, I have a negative and a negative. Negative times negative gives you positive. All divided by the bottom squared. You can FOIL it out if you want. I'm not going to FOIL it out. I'm going to leave it x squared plus 1 all squared. Something nice happens. Actually, two nice things happen. The 2x cubed and the minus 2x cubed cancel, and the 2x and the plus 2x add together. And we get 4x over x squared plus 1 all squared. That's our answer. Simplified form of the solution. We just got to take it. We got to trust it. Okay, we'll do another one. This one is linear terms, top and bottom, and we can't split this one up either. So this is a top function over a bottom function. H prime of x is bt prime minus tb prime all over b squared. Okay, so the bottom function is 5x minus 6. And then we have the derivative of the top. Derivative of the top is 3 plus 0 minus tb prime, so the top, 3x plus 2 times the derivative of the bottom, which is 5 minus 0. Derivative of 5x is 5, derivative of 6 is 0, so 6 is a constant. All divided by the bottom squared, 5x minus 6 all squared. Now we can simplify. Multiply the first two brackets together. We have 3 times 5x, so 15x. And negative 6 times 3 minus 18. And now we do this the same for the next brackets. Negative 3x times 5, so minus 15x. And then minus 2 times 5 minus 10. So that minus hits both pieces in here. I can do the same thing. I should do the same labeling here. Okay, now we have 5x minus 6 all squared. And something glorious happens. 15x minus 15x, they destroy each other. We can merge the negative 18 and the negative 10, give us a negative 28. Okay, that's the answer for that one. Okay. One more. This is a top function over a bottom function. We don't have any alternative than to do the quotient rule. I'm going to break this one up into pieces. So when we calculate h prime of x, it's still what it was before. bt prime minus tb prime all over b squared. But each of the things we're plugging in there is pretty nasty. So b, we have 1 plus 4 root x. And I'll put here an extra instruction. do not simplify. That's a typical instruction you would see on a test, if the function looks like this at least. So 1 plus 4 root x times, I'll leave a box for b prime, for t prime, minus t, so x to the 7 minus root x, and I'll leave a box for b prime. All divided by the bottom squared, 1 plus 4 root x all squared, which by the way is not 1 plus 16x. There's a cross term in there. Foil it out if you want to expand it. If you don't want to expand it, leave it alone. Leave it exactly like that. Anyway, let's figure out what we're going to put in those boxes. T is equal to x to the 7 minus x to the power of 1/2, since that's the square root. T prime is going to be 7x to the 6 minus 1/2 x to the power of negative 1/2. Power gets reduced by 1. I'm going to put that directly in the box for t prime. 7x to the 6 minus 1/2 x to the negative 1/2. And then for b is 1 plus 4x to the 1/2. So b prime is going to be 0 plus 4 times 1/2 x to the negative 1/2. So that's going to be 2 x to the negative 1/2. Okay, and since the question says do not simplify, that's it. So that gives you a selection of question types that involve the quotient rule. As a recap of the last two videos, we saw a new derivative law or derivative rule called the product rule, which works when you have two functions multiplied together. You can call them f and g, or we could say if h of x is a times b, then h prime of x equals a times b prime plus b times a prime. There's many, many different ways the formula is written, but they're all essentially the same. And then a recap of the quotient rule is that if you have a top function over a bottom function, or you have f over g, then there's the bt prime minus tb prime over b squared formulation for the derivative, or there's the gf prime minus fg prime over g squared formulation. Both agree with each other that they're just different ways to label a top and bottom function. T and b is a little bit better because sometimes the whole function is called f, and now you have f appear twice in different ways, and it's confusing. Oh, I almost forgot the most important example, the test style example. It's also important for other reasons. It's important because it's data, and it's very rare that in an application you actually have functions. You usually have data. So in this question, we've been given data about f of x, g of x, f prime of x, and g prime of x at different x values. At x equals 4, x equals 5, and x is equal to 6. And we need to use some of this data to solve parts A and B of the question. Part A, find h prime of 5 if h of x is equal to f of x times g of x. So this is a product rule. This is a times b. H prime of x is ab prime plus ba prime, which isn't very helpful because it's just f of x times g prime of x plus g of x times f prime of x. I mean, have we really gotten anywhere? Well, let's continue. Let's plug in 5 for x. H prime of 5 is equal to f of 5 times g prime of 5 plus g of 5 times f prime of 5. Now look at the table. So this is for part A. We're going to need f of 5, which is negative 2, g prime of 5, which is 0, plus g of 5, which is 1, times f prime of 5, which is negative 4. So that's going to be 0 minus 4, which is negative 4 is the answer. Okay, part B. This one is a quotient, g of x over f of x. So we have to use the quotient rule. I'll change colors so it's easier to read later. I'll call the top function t and bottom function b. And if you are going to be using the f and g formula, you're probably going to get this derivative wrong because they've been switched. The top is called g and the bottom is called f. In the other formula, it's reversed. F is on top, g is on the bottom. So t over b saves the day. Let's take the derivative. W prime of x equals bt prime minus tb prime all over b squared. So the w prime of x is equal to, well, I can't plug anything in except what the functions are. B is f of x times t prime times g prime of x minus t, so g of x times b prime, so times f prime of x, all divided by f of x all squared. Now we'll plug in 5. W prime of 5. So, oh, it's 4. Sorry about that. W prime of 4. I misread the question. So I'll label that one with green. We need the top line. So f of x, uh-oh, don't do that. So f of x, f of 4 is 2. Then g prime of 4 is 5. G of 4 is 3. And then f prime of 4 is negative 7. And then all divided by f of x all squared. F of 4 all squared. So that is 2 all squared. And then we'll simplify. 10 plus 21 over 4. So we have negative times negative for those two terms on the right and on top. So positive. 3 times 7, 21. And that's going to be 31 over 4. Okay, that's it. See you in the next set of videos.